Let's take a break from talking about the structure of the periodic table to talking about a little bit of history on how it came about. Um, and as with most discoveries in science, there are very few lone heroes working on their own. But there are generally those who get credit for major breakthroughs at particular points in history. There were plenty of chemists and physicists in the late 19th century who were starting to consolidate the data on discovered elements and their various masses and properties. And key among these figures was a Russian by the name of Dmitry Mendeleev. And what Mendeleev did was, well, he existed at a point in history where there was sufficient data to start investigating whether or not patterns existed in this data. So a significant number of elements had been discovered and measured, isolated as, in fact, elements and not compounds. And so what Mendeleev was able to do was to see some patterns that others had not, or at least consolidate a group of patterns into a meaningful approach. This is an image on the right here of some of the organization of his data, and you may notice that it's tilted to 90 degrees from what we would normally see on the periodic table. But he's beginning to organize things into groups. He's beginning to organize them in terms of repeating chemical patterns, and he's also noticing that there are gaps in these patterns, to which he makes some predictions about things that will in fact be discovered based on those patterns. Here is from a translation of Mendeleev's work called Principles of Chemistry. It was published in 1891, and this is one of his major tables of the organization of the data that he sorted out. And so there are various properties, melting points, boiling points. Some interesting things here are the compositions of elements with other elements to form compounds. And here's where you begin to see some of these patterns emerge. And so here we have the list of hydrogen containing compounds. So you have boron, which will form a simple boron hydrogen compound with 3 hydrogens, and carbon, which will form it with 4, but then nitrogen back down to 3, oxygen, right, H2O, so 2 hydrogens and oxygen form water, fluorine will form 1, and then we count back up and then back down, and so you have this repeating set of patterns. And then, of course, there is a bit of a gap here where he does not yet have data and or they don't fill this pattern, but then watch the pattern reemerge. Of course, we know from looking at the periodic table that this gap is elements filling d orbitals, which are going to have different chemical structures than things filling p's and s's. Again, here we are with oxygens, and so you can see this kind of almost evergreen tree-like pattern building up of increasing combinations of oxygens and elements, and then decreasing and then increasing. And so these reoccurring patterns are how he organized the table. One of the kind of explanations for how he went about doing this was he in fact just made note cards, like a game of memory, with all of the elements on them, and then rearranged, restructured the elements in a kind of table form before he solidified it as he got new data, and eventually settled on this structure. And again, in settling in this structure, he recognized that there were gaps in the structure. And what he was able to do with those gaps and kind of a reading off of the pattern was to come up with some fairly accurate data describing what the elements that had not yet been discovered would look like, or what properties they would have. And so here you have in 1871, after amassing all this data, Mendeleev predicts that there is an element near aluminum on the periodic table, which he referred to as Eka aluminum. And in 1871, he predicted that it would have an atomic mass of 68. It would have a density of 5.9. It would have a relatively low melting point. That its formula with oxygen would be that element in a ratio of 2 to 3 with oxygen, and that the density of that oxygen compound would be 5.5 grams per centimeter cubed. In 1875, the element gallium was actually discovered for the first time. And look at how close these numbers match up to Mendeleev's predictions. The density off in the hundredths place, right? The melting point at 29.8. Gallium's a really interesting metal in that its melting point is above room temperature, below human body temperature. So you can take a hunk of gallium, put it in the palm of your hand, and it will melt. Set it back down on the table, and it will re-solidify. There are all kinds of fun videos on YouTube you can look up about that. Melting point, he got pretty darn, we just talked about melting point. The chemical structure of the oxide, he was right on and got pretty darn close to even the density of that oxide. So he predicted the properties of a compound with an element that had not yet been discovered. This is a pretty phenomenal set of discoveries here. If you look on the periodic table, right, gallium is right below aluminum, hence its terminology as Eka aluminum. At the same time, he also predicted an element removed from silicon, or just below silicon on the periodic table. It had also not previously been discovered, so 1871, he makes the prediction, the following set of predictions about the properties of Eka silicon. And so you can look through that list of properties, and again, the predictions are really, really spot on. It's really interesting here also, if you look right here at the melting point. Gallium and germanium are also right next to each other on the periodic table. Those two gaps were side by side. Gallium, as we noted, had that extremely low melting point. It will melt in the palm of your hand. Germanium's melting point is almost 1,000 times that of gallium. That's a pretty significant increase in melting point. And so one element over on the periodic table has significant impacts on the chemical properties. But then you can look through all of these, and there are some pretty startling ability to predict what those elements would be. Just as a side note, the terminology Eka aluminum and Eka silicon, these are Sanskrit terms, which mean essentially one removed from. So Eka aluminum was just one removed from aluminum on the periodic table. There were other predictions that Mendeleev made that were equally startling. And again, I can't stress that it is a certain feature of the history of science that a certain amount of data collection has to precede discovery. And so Mendeleev certainly had insights that other people of the time didn't quite jump to. But it required a tremendous amount of previous work to catalog this information. And there was very little experimentation Mendeleev did on his own. Most of it was a summation of other people's work and an organization in a way that no one before had done.